Hello, Nareg is here. Today I'm gonna solve the second session of 2019 chemistry, the first exercise, which is linked to the part related to atoms, but also we have a little bit of organic chemistry. So let's start. Alert from methane. When talking about global warming, people think immediately about the release of carbon dioxide gas, CO2, but few think about methane. Methane is responsible of 1/3 of global warming since 1750, while the emissions of carbon dioxide start to become stable in certain countries that of methane increase since few years in a worrying rhythm. So this is simply a small text taken from an article. Document 1 represents a circle graph pie chart showing the sectors responsible of the emission in 2012 of methane gas in kilotons. So KT represents the unit kilotons. Refer to the text and document 1 and answer to the following questions. Name 2 gases responsible of global warming. So from the text, we already know that there is carbon dioxide. This is the first gas. And the second one is methane gas. These are the 2 gases that you should mention. Name them as gases responsible for global warming. Which sector emits the highest quantity of methane gas in 2012? So regarding document 1, whenever you're checking your pie chart, as you can see, this sector, which is related to fossil energy with a unit of 134 kilotons, is the highest sector responsible of emitting, is the sector actually for responsible of emitting the highest quantity of gas methane. Document 2 represents the molecular models of carbon dioxide and methane. Refer to document 2. Answer the following question. Verify that model A corresponds to a methane molecule. So first let's check model B. Model B is a molecule formed by carbon and 2 oxygen. So in this case, I can forget about model B as being methane. So model A should be methane gas, and in reality it is formed by a carbon, hydrogen, and again just once, yes, carbon, hydrogen. All right. So you can say that CH4 is actually in model A, which is CH4, represents the methane gas. Now what about the second question? Identify the type of bond established by carbon atom in each of the following models A and B. In model A, which is CH4, C is actually making a bond which is covalent but simple. You have C with 1 electron, H with 1 electron, so 4 hydrogens sharing their electrons, their each unique electrons with the 4 celebratory electrons of carbon in order to form 4 simple covalent bonds. As for CO2, in the case of CO2, you have carbon, which is linked to the oxygen by a double bond, so it's a covalent double bond. The oxygen is sharing is 2 electrons. As for the carbon, also it's 2 electrons. So we have a couple of, so we have 2 double covalent bonds in this case with 2 different oxygens. So this was about the bond which is established. Oxygen atom has certain characteristics. Choose among the propositions given below the ones that corresponds to oxygen atom OH16. Justify your choice. So we have electrons of oxygen atom occupy 3 energy levels in the ground state. So whenever you have, this is the part 3a. So whenever you have O816 and the atom is electrically neutral or in the ground state, you can do the electronic configuration, which is K2L6. The number of electrons is 8, so you have to occupy, they can occupy 2. They can occupy, they just mentioned about energy levels, so you have to say energy levels. They occupy 2 energy levels, which are K and L, and not 3. So this is the first statement was false. What about the second one, 3b? The valence of oxygen atom is 2. So after establishing the electron represent configuration of O816, which is K2L6, I can do the Lewis representation of oxygen, which is like this, and then you will have 2 celebratory electrons, and from that point of view you can say that the valence is 2, so this is a true statement. 3c, oxygen atom has 16 charged particles. It's true. The atom is formed by electrons, neutrons, and protons. Neutrons, they do not have any charge. So we are interested in the charge of protons, and we are interested in the particles which are charged, so protons and electrons. And since it's an atom, normal atom in its ground state, so it will have 8 protons and 8 electrons. So in total I will have 16 charged particles. All right, this was for the part 3c. 4. Methane is one of the raw materials used in organic industry. When exposed to light, methane can react with chlorine gas according to reaction R, represented by the following equation: CH4 plus 4Cl2 plus CCl4 plus H. It gives us CCl4 plus 4HCl. Now, given the oxidation number, so we have the oxidation number of the element carbon in it is plus 4. Calculate the oxidation of carbon element in the compound CH4. Very simple. In order to calculate that, you simply, so this is 4.1. Let F be the number of oxidation of carbon in CH4. So in this case you will have number of oxidation of carbon plus 4 times the number of oxidation of hydrogen is equal to 0. So I will have x plus 4 times plus 1 is equal to 0. X plus 4 is equal to 0. X is equal to minus 4. So the number of oxidation of carbon in CH4 is minus 4. Now what about the last question? Regarding the last question, we have deduced that methane gas is the reductant in the reaction R. So I will have to write down the reaction. I will write down the reaction. We have CH4 plus 4Cl2, which gives us CCl4 plus 4HCl. Now the number of oxidation of carbon in CH4 we already calculated, it's minus 4. As for the number of carbon in CCl4, the number of oxidation of carbon in CCl4 is plus 4. So as you can see, the number of oxidation from minus 4 to plus 4, it is increasing. So the carbon is going through what we call oxidation. So since we have a certain oxidation, so CH4 is a reductant. This is how you justify your answer. All right, that's all for this exercise. This was exercise 1 from second session 2019 chemistry. I will ask you to subscribe to my channel I'll be uploading new material. I will solve other sessions. I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. That's all for this time, and see you later.